What volume of 0.123 m KOH solution is required to completely neutralize 14.26 milliliter of 0.345 m phosphoric acid solution? What volume of 0.123 m KOH solution is required to completely neutralize 14.26 milliliter of 0.345 m phosphoric acid solution? This is the chemical equation. KOH plus H3PO4, we get K3PO4 plus H2O. This chemical equation is not balanced. Let's balance it. Then on the left hand side 3KOH plus H3PO4, on the right hand side K3PO4 plus 3H2O. You can see on the left hand side 3 potassium, on the right hand side 3 potassium, on the left hand side 7 oxygens, on the right hand side 7 oxygen, on the left hand side 6 hydrogens, on the right hand side 6 hydrogens, on the left hand side 1 phosphorus, and on the right hand side 1 phosphorus. This is the ratio to react with 3 moles of KOH, 1 mole of H3PO4 is required. In the same way, to react with 1 mole of H3PO4, 3 moles of KOH are required. We know the molarity and volume of the phosphoric acid solution. Therefore, we can find the number of moles in 14.26 milliliter of this phosphoric acid solution. Volume of this phosphoric acid solution is 14.26 milliliters. Volume. Molarity of this phosphoric acid solution is 0.345 m. M means molarity, that means in 1 liter or 1000 milliliters of this phosphoric acid solution, there are 0.345 moles of phosphoric acid. Now we need to find in 14.26 milliliters of this phosphoric acid solution how many moles of phosphoric acid are there. In 1000 milliliters of this phosphoric acid solution, there are 0.345 moles of phosphoric acid. Because this is 0.345 m phosphoric acid solution, therefore in 1000 milliliters of this phosphoric acid solution, there are 0.345 moles of phosphoric acid. Then in 14.26 milliliters of this phosphoric acid solution, how many moles of phosphoric acid are there? You can find the answer in this way: 0.345 moles of phosphoric acid divided by 1000 milliliters phosphoric acid multiplied by 14.26 milliliters phosphoric acid. In this way, we should cancel out units. Milliliter phosphoric acid, milliliter phosphoric acid, then we get 0.0049197 moles of phosphoric acid. In 14.26 milliliters of this phosphoric acid solution, there are 0.0049197 moles of phosphoric acid. We know the ratio, we have found it earlier. To react with 1 mole of phosphoric acid, 3 moles of KOH are required. To react with 1 mole of phosphoric acid, 3 moles of KOH are required. Now we have 0.0049197 moles of phosphoric acid. Then to react with 0.0049197 moles of phosphoric acid, how many moles of KOH are required? You can find the answer in this way: 3 mole KOH divided by 1 mole phosphoric acid multiplied by 0.0049197 197 moles of phosphoric acid. In this way, we should cancel out units. Mole H3PO4, mole H3PO4. Now we get 0.014759 1 moles of KOH. Now we have to find the volume of this KOH solution. We know molarity of this KOH solution. It has been given 0.123 m. Molarity of this KOH solution is 0.123 m. That means in 1 liter 1000 milliliters of this KOH solution, there are 0.123 moles of KOH. Therefore, there are 0.123 moles of KOH in 1000 milliliters of this KOH solution, because this is a 0.123 m KOH solution. Now we have 0.014759 moles of KOH. This amount. We have 0.014759 moles of KOH. Are they in how many milliliters of this KOH solution? We can find the answer in this way. 1000 milliliters KOH divided by 0.123 moles of KOH multiplied by 0.014759 moles of KOH. In this way, we should cancel out units. Mole KOH, mole KOH. Then we get our answer. Volume is 119.99 milliliters KOH. Volume of this KOH solution is 119.99 milliliters. Second method. There are two chemical solutions here. One is phosphoric acid solution. The other one is KOH solution. We can take this phosphoric acid solution as number 1 solution. KOH solution as number 2 solution. There's no problem. If we want, we can take phosphoric acid solution as number 2 solution, KOH solution as number 1 solution. There's no problem there. Now we have taken this phosphoric acid solution as number 1 solution. Therefore, we can take molarity of this phosphoric acid solution as M1, volume of this phosphoric acid solution as V1. We have taken KOH solution as number 2 solution. Therefore, we can take molarity of this KOH solution as M2, volume of this KOH solution as V2. M1, we know 0.345. V1, we know it has been given 14.26. M2, we know 0.123, it has been given. These values have been given, but we don't know V2. We have to find it. Now we can create an equation like this. M1V1 equals M2V2. On the left hand side and right hand side, units are same. We can substitute these values to this equation. Let's substitute them. M1 0.345, M1, V1 14.26, M2 0.123, V2 we don't know. Ratio is very important because we know ratio to react with 1 mole of phosphoric acid, 3 moles of KOH are required. Therefore, we have to multiply phosphoric acid side of this equation by 3. I have written this line here again. 0.345 times 14.26 equals 0.123 times V2. We have to multiply phosphoric acid side of this equation by 3. Then 0.345 times 14.26 times 3 equals 0.123 times V2. Here we need to find V2, therefore we have to isolate V2 on the right hand side of this equation. Then 0.123 goes to the left hand side. In this way, 0.345 times 14.26 times 3 divided by 0.123 equals V2. V2, by simplifying this, we can get the answer 119.99 V2. Volume of this KO solution is 119.99 milliliters V2. Thank you very much for watching this video. Please subscribe our channel. God bless you.